series has been going on for the last month, and we're wrapping it today. Dr. Linton is here in the afternoon, and then we have one more event today at 6 o'clock in McAfee Gym. If you would like to experience sports and dancing from ancient Egypt, we hope you will come. There will be live music, dancers, and athletes, in addition to a lecture. So we hope you'll join us there. But I certainly thank you for all your patience and expert listening over the several sessions here. Our friend here has been to almost every one. Did you miss one? I don't think so. Yes, look at that. So for 24 presentations, I think, we deserve an award there. I will leave you with Dr. Wafiq Wabi, who has expertly gathered all our speakers for this series.
Thank you, Dean Lanham, and thank you all for coming at this time at 3 o'clock on a Wednesday, which you can do something else on that time slot, but thank you very much for coming. And this marks the last day of this symposium, the Ancient Egypt Symposium, popularly known as a futuristic look through ancient lenses. And it has been a joy to know more about this ancient civilization that was it was the United States of its time, I think, and they left some things for us to get a glimpse of their glory. Well, stars are fascinating and have been fascinating to people since the dawn of history. Even the dawn, you can see some stars. And you can mention, even today, the word stars, and you get millions of responses. People like to be stars themselves. Look at Hollywood, if you like, or anywhere. Everybody likes to be a star. And one wise person said that 2 days ago, we had 7 billion stars, the population of the world. Everybody thinks or likes to think that he is a star. All the parents like to see their kids stars. So we had the 7 billion mark of world population 2 days ago, if you like to know that information. Now, to introduce sciences, stars, and our distinguished speaker, I'm thankful for our dean. Would you please give us a hint of what you do in sciences?
My name is Godson Obi. I'm the interim dean of the College of Sciences, and I have missed most of the presentations because of all the engagements on campus. But this one, I made time to come to. Dave Linton is my faculty member in physics and one of the well-known professors on campus because of his expertise in astronomy. Am I right? Okay. So today he's going to apply some of that science to an understanding of ancient Egypt. And Dave, good luck.
Now, if you wish upon a star, here it is.
Thank you both, and thank you all for coming. I would start off by saying that I noticed that all the slides seem to be shifted that way, so if you'll just lean, maybe it will help. But you're probably going to, could be. That's maybe the early indication that you're going to miss a little bit off the right edge, and if that happens, hopefully I can remember what it was, because I can't see it on my screen here either. But the stars, the sky, was extremely important to the Egyptians. Remember that this was a time when there was no light pollution on this planet. And this is a desert environment, and the skies were just gorgeous. It must have been. We can only imagine if we're here in Illinois, where it's not all that arid, fortunately, I guess. And we do have some light pollution. Now, before I get going very far, I do want to, I have 3 disclaimers. One, if you're expecting a talk on astrology based on the mistake that got into the paper yesterday, you may want to leave now. There is a difference between astrology and astronomy, and I wish to speak on astronomy. Secondly, I'd have to say I'm not an expert on Egypt at all. although I have significant interest in the history of astronomy, as it bears on astronomy itself. And thirdly, I've never even been to Egypt, although it's on my list. More so now than when I started reading up for this talk. So I guess maybe the next slide to look at is this that was in the paper yesterday, and I don't want to make fun of this. It was as much my mistake, probably more my mistake than anybody else's. I wasn't careful about communicating over the phone in a phone interview what I should have been alert to as a very common misconception and confusion. Astrology and astronomy are not the same thing. There's a lot of, yeah, even missing the punchline in this cartoon. That's bad. I always get mixed up between astrology and astronomy. Which is the stupid, trivial one, and which is the one you get horoscopes in with? But astronomy is a science. Another one I will just skip through here. Astrology, really a pseudoscience. It really is an ancient religion. It was a religion at a time in a variety of parts of the world, certainly in the Middle East, when motions in the sky were quite mysterious. It was trying to make a sense of life and looking for correlations. Certainly there were seasonal correlations to be found in the heavens, timing of various things such as lunar phases and seasons as well, with ripening of berries, for example, or patterns of game. And they looked further, and they came to the conclusion, or had the belief system, that where things were, where planets were, where the sun was amongst the stars, would have a bearing on what one's destiny might be, and that sort of thing. And the predictions of astrology can now be tested, many of them, with scientific methods, and they don't stand up. And at that point, I guess you stop calling it an ancient religion. You say if you have a current belief in it, you're having to do some mental gymnastics to get past the evidence that says that where a star is or where a planet is simply doesn't have any effect. But as I read that article and then thought about it a lot, because my initial reaction was just, oh my goodness, I realized, it really is something that maybe I should mention here. Astronomy has matured. We've learned things. Well, that's true in any science or any discipline, I would hope. And at the time the Egyptians, the time we're talking about in ancient Egypt, astronomy was not what it is today. We didn't have telescopes, a long way from it. And astronomy and astrology were really one and the same. The priests were looking at the stars, they were mapping them, they were timing them, seeing when they set, when they rose. Same thing for the sun and the moon. Planets, where they were in certain constellations, but also trying to give the king his what he was requesting, his whether this is a good year to go to war, perhaps, with the neighboring countries. So astronomy and astrology, I'm sure I'm talking about both today. Now, I have never been to Egypt, but I have been to Africa. And I will say that I have been to the Sahara Desert. I've been on a camel. My wife and I and two of our children 11 years ago for semester break went to Morocco. And we rode camels into the Sahara Desert and on Christmas Day, no less, and spent the night. And I even, in the bazaar at Marrakesh, got to hold a cobra. Checked that one off, not going to do it again. Saw a sign that said Timbuktu, 52 jours, meaning 52 days, this way, by camel, 52 days. That was in the oasis that we encountered that I had rented the camels, and we went out to into the Sahara. So I've seen the western end. I haven't seen the eastern end of the Sahara. Now, the sky, this part of the sky was one of the most special parts of the sky for the Egyptians. We know this is our winter sky. These constellations are there in the early evening in our winter. You see Orion there. The two knees, the three stars in a row for the belt, the two shoulders, the star that is red at the top, one of the brightest stars in the sky. Betelgeuse is how it's usually mispronounced. Betelgeuse, probably a bit better. The knee at the bottom is blue. These are two stars that are decidedly different in temperature. But different in temperature, the cooler star and the warmer, much hotter star, the blue one. Over here, the brightest star seen from the Earth. This is the star Sirius, S-I-R-I-U-S. And then in the upper right, we have Taurus the bull. We have the face of the bull. It's a V-shaped face right here. I'd jump up, but probably would not be good for me. Okay, V-shaped face, the star Aldebaran, the eye of the bull, and over here the Pleiades, also known as the Seven Sisters. Now, if you look low on the left, you see a transitory object, a meteor, passing behind the trees. Got caught in this photograph here. Sirius is in the constellation of the dog, Canis Major. That's the name it's given now. To the Egyptians, Orion came to be associated with one of their gods, Osiris. And Sirius came to be associated with Isis. I think I've got some more slides here. Yes, there's Orion. Better view of it there. A lot of faint stars, stars that you cannot see from here under the lighting conditions that we have. Here is a depiction from somewhere in Egypt at some time. I don't know what the source of this is, but we have Osiris being associated with what we now call the hunter, and Isis, I'm sure that's what this must be, right here. Remember, in fact, you can see here the belt. Remember from the previous slide that if you go down to the left past the belt is pointing really to the star Sirius. Sirius is a star that rises in our southeast. It doesn't get real high, but it's very noticeable. It's exceeded in brightness only by the sun and the moon, and by Venus, and I think Jupiter at times is brighter than it is. Jupiter's in our sky right now in the east. If you go out any time of the evening after the sun is set, it will be there for you. And Venus, even brighter, is now entering the western sky, but very early only. Isis again, making a trek across the sky. Now Sirius I'll talk more about. In fact, right here, the flooding of the Nile River, that was vital to the survival of the civilization and survival of the individuals within that civilization. Most important annual event in Egypt. Timing this, foretelling when it was going to happen, was a really important task that was given over to the priesthood. They found an astronomical association with this, correlation, and that was the rising of Sirius. So what happens is that as we go around the sun, the stars that are behind the sun change. It looks to us as though if we could see the stars and the sun at the same time, and that's tough, but you can imagine that the sun, if I put something in the middle of this oval right here and I walked around the table, it would look to me as though that object in the middle was moving in front of the background individuals here. The sun seems to move through the stars. Now, at a certain point in the year, it gets roughly in the direction of Sirius. Not exactly, but enough so that with all that light, it's going to make Sirius impossible to see. And then it goes past Sirius. And if you're watching early in the morning, looking to the east before sunrise, the day will come when Sirius can be seen rising just before the sun. It's separated itself enough from the sun. And it was at that time that the Nile was found to be flooding in the capital city of Memphis, probably flooding further south earlier. Now 70 days, over that time span, Sirius cannot be seen due to its proximity to the sun. 70 days. What you can't see too well is this slide off to the right. This is Osiris. A green-skinned god, God that came to be associated with Orion, and loosely with Sirius as well. And remember that these constellations disappear for a while. Remember that Osiris, or I haven't mentioned it, but you may know, Osiris is the god of the underworld. This is mythologically associated with the passage from life, gone to the underworld, and this is the one god from ancient religions that actually was resurrected, had a resurrection, came back to life, but life was now being placed in charge of the underworld, the afterlife. The calendar is associated very strongly with Sothis, which was one of the names that was used for Sirius. Sothis or Sothis. Sopdet, I believe. Trying to pronounce some of the words I forget. But what they did was to start the year initially with the flooding of the Nile. Started with the rising of Sirius just before the sun. They created a calendar that had 12 30-day months in it. The months were 30 days. The lunar cycle is 29 and a half days for the cycle of phases. So they were doing pretty much the same thing we do today in terms of the lengths of the months. But that would just give you 360. They had 5 days of feasting at the end. Not fasting, but feasting. That E makes all the difference. And 3 seasons of 4 months each. The first season was the season of the flooding of the Nile, the rise of the waters, the cresting of the waters, and the subsiding. The next season was the season of cultivation, and the last season was the season of harvest. Now, the 5-day feasting was said to be unlucky for any work to be done. And we have a 365-day year. Now, how long is our year? Any astronomy students around? 365 and a quarter is a whole lot better, yes. So the day the year is off by about 6 hours. 365.2422 days, that is the length of the year as we now understand it. So if they had 365 days in it, there were about a quarter day off, 6 hours, and so every 4 years they were going to be a day out of sync, their calendar was, with the flooding of the Nile, if the Nile is that regular. And eventually, any variation that it had was swamped by the difference between the calendar and the flooding. This quarter day was adding up. Over 1,460 years, the rising of the Nile cycled through the seasons. The priests knew about the quarter day discrepancy, but they didn't care. The calendar had been created. Maybe they couldn't think of what to do, but they did notice that the stars were a better predictor of the rising of the Nile than their own calendar. 1,460 years. I think it's a testament to the duration, the longevity of the Egyptian civilization that they got to see this cycle through their calendar twice after they created the calendar in about 3000 BC, I think. I think that's about when it was put together. Eventually, 46 BC, we have Julius Caesar modifying the calendar by adding that February 29th every 4 years. But if you've paid attention to the news lately, it was in 1582. Much more recently, Pope Gregory VIII. That's 13, isn't it? Yeah. 13. Okay, he modified the calendar again because adding 6 hours on the average, adding that 1 day every 4 years is too much. That would make it at 365.25, and really it's just slightly less. So the century years are leap years only if they're divisible by 400. 2000 was a leap year. Probably none of the rest of us need to worry about any more of those, but come 2100, you can warn your kids, your grandkids, it's going to be different. Now that I think I have mentioned all of this, yes, the rotation of the Earth is very steady. Just summarize it by that. Now, it's interesting to note that the priests were watching the sky, and I'm going to be focusing on one more thing that they were doing especially. They were keeping records, but there are certain things that they didn't notice, things that their neighbors to the east, the Babylonians, did over the course of several thousand years. They noticed the Saros cycle, 18 years, 11 days, 8 hours. Now, this wasn't actually noticed by the Babylonians until the reign of Nebuchadnezzar, I believe it was, in the 8th century BC, where he really promoted science. It was said by Claudius Ptolemy some 1,000 years later, almost, a little bit under that, that was really the beginning of real astronomy right there. He asked his astronomers to pore through the records of old. They've been keeping records, but now take a look at them, see what you can find. And what they found was that eclipses happen in cycles. And for example, if you mark in your calendar, August 21st of 2017, head to Carbondale, because that's going to be the center, on the center line of the next solar eclipse in this part of the world. And 18 years, 11 days later, that would be 2035. We have another one, and I believe it is this one right here. I think that's it, but I think it's off the screen in terms of the labeling. Why is it in another part of the world? Because of the extra 8 hours. The Earth gets another 8 hours to rotate, so that puts it further west by 1/3 of a rotation of the Earth. And then in 2053, September 12th, again advancing forward 11 days, although it may seem like only 10 in some cases. It depends how many leap years are in between these particular dates as to whether the dates really seem to be 11 days apart. But we're going to have another one in this same cycle, and this one actually passes apparently right through Egypt. There are other cycles going on at the same time. We don't have to wait 18 years between eclipses. Other cycles are happening as well. They discovered this by looking at the data. For example, if we go to 2024, we get to see another solar eclipse, and if you happen to be in Carbondale, you can just wait for from 2017 to 2024, just sit there and wait, and you have the shadow of the moon passing across you. And others happen too, but this is just a different Saros cycle. Also, the Babylonians were paying attention to the planets and discovering some things about the planets. The planets, for example, are changing directions. This is Mars at probably about a 1-week interval, photographed against fixed stars. And obviously, the stars are moving across the sky, but if you freeze those in your frame or on your print, then Mars is a wanderer, and that's really what planet means, wanderer. They didn't know what the planets were, associated them with gods, goddesses, Mars and Venus, for example, the Roman names for god of war and goddess of love. But this changing of direction like this was really very difficult to explain. And they worked on the timings, trying to understand that. The Egyptians, though they were aware of these phenomena, didn't pour into the data to find the cycles, didn't seem to be that interested in this phenomenon either, and probably the reason was that it didn't correlate with the flooding of the Nile at all. That was survival. When I talk about bringing astronomy down to Earth, bringing the sky down to Earth, their focus was on survival. Focus was on that flooding of the Nile, keeping the king happy. That's always a good idea. By the way, up here you see the Pleiades again. Looks like a little dipper. And anybody know what Pleiades means in Japanese? Yes, you do. Some of you do. Next time you see a Subaru vehicle, look for the stars on it. That's the emblem, and that's what that means. From the African continent, further south than Egypt, we get a glimpse, perhaps, an idea of what the skies of old must have been like. This is the Milky Way, photographed from Botswana, and the southern Milky Way as well. You have the dust lanes that lie between the stars, the dust from dead stars that's built up there and dims the more distant objects in the sky. Really, the dust lanes are the densest parts of the sky. Take a look at this glyph, I would call it, I guess, is general, from Egypt. What you have here is the sky goddess, and her name is spelled N-U-T, and I believe it's pronounced Newt. And what does that look like to you? Maybe I shouldn't ask it in such open terms, but I'm trying to correlate it with the Milky Way arching overhead. What you've got also is the earth god, Geb, separated from the heavens by the god of the air. It's holding up and keeping the two apart. Other things are in there, and I don't think I'll go into those. Another one that I would suggest to you is this one. Many times you see the goddess Nut symbolized with star representations along her body. That's same thing. Okay. Now let's turn our attention again in Africa and look to the south. And south point on the horizon, right below the center of these circles. This is a 2-hour exposure of the southern sky from south of the equator. And what you find is that the stars are rising in the east, well, the ones that do at least. This is due south, so east is over here. So some of the stars out here are rising in the east, going around the pole, the point that's overhead, the south pole of the Earth, and then setting west of due south. They're moving in clockwise circles. They do the similar sort of thing in the northern hemisphere. If you look towards Polaris, they are moving in circles, but they're moving again from east to west, but now because you're looking the opposite direction, it's counterclockwise. And the stars within this circle are the stars that would be circumpolar as seen from roughly Alexandria. Alexandria is at a latitude of about 31 degrees. We are closer to 40 degrees. And consequently, the stars that are always overhead, always above our horizon more correctly, are the stars that come right down to the bottom of the screen. The Big Dipper skims the northern horizon at its lowest point and gets up to an altitude that's almost straight overhead, about 80 degrees tops when it's highest in the sky. The point Polaris, or right close to Polaris, is the point amongst the stars that lies exactly overhead the North Pole of the Earth. And as Earth rotates, as we now understand, the stars look like they're moving. Really, we're turning. But that turning and along this axis makes that point seem motionless. If you're at the North Pole, point straight up, and the Earth turns, you keep pointing at the same spot amongst the stars. That's less than a degree away from Polaris, so that is our North Star. Okay. To the Egyptians, the northern stars gave a permanence, a sense of permanence. They're always there. They're north of the equator, so their attention is going to be drawn much more to the northern sky than to the southern sky for any sense of that. And for the pharaohs, the belief arose that once they would die, they would have a chance at immortality through being transported to the northern sky, where you'd always be up there, become one of those stars, one of those 7 billion stars, except at night you don't quite see 7 billion, but there's a lot of them out there on a clear night. Now, we've got the 2 pointer stars there that help us, in the Big Dipper, that help us to find Polaris. The problem is that the pole star is wandering. Not the pole star, but the pole is wandering. Why does it wander? Because the Earth is wobbling. If you, and I think maybe I'll just look ahead here. If you take a top and you spin it on the kitchen table or the kitchen floor, some hard surface, spin it, with it leaning, it's going to spin, its axis doesn't keep pointing in the same direction. If you don't spin it, it falls over. But if you spin it, you get this precession right here. The Earth is spinning like a top, and it's not sitting on the table, but gravity's pulling on it. Gravitational pull of the sun and the moon are trying to get it to fall over. It's got an equatorial bulge. The equatorial diameter is about 70 kilometers more than the polar diameter. Trying to get it to fall over. But the spinning causes it to do this. It takes 26,000 years for the pole star to switch from Polaris to Vega and back to Polaris, for example. But we're looking at a time when the sky was a bit different. We look back to 3000 BC, and the North Celestial Pole, the point directly overhead the North Pole of the Earth, was very close to the star Thuban in Draco. I think it's also known as Draconis. Since then, it has moved along. Finally, we get to Polaris, and then about now, close to Polaris. For the pharaohs entombed in the pyramids or in other burial sites, they had, according to their beliefs, they had to prepare to go north. So what the priest did was to line up the buildings along the north-south axis. And of course the opposite sides, the adjacent sides, would be east-west. How do you do that? Well, the technique in about 2500 BC was to focus on the star Kochab, and the star down here at the bend of the handle of the Big Dipper, known as Mizar, M-I-Z-A-R, because the pole was directly between these 2 points. Now, this is 3000 BC, but as you move along right here, as the pole does, it's right here. So they could find that. They knew by watching during that time that that was due north, but these 2 stars flanked the pole star perfectly. They're equidistant. And they were kind of like, I use a phrase that's actually applied to a couple of other stars, the guardians of the pole. They were the guardians for the pharaohs, really. So it lined up for this. Well, what happens? They keep doing this over time. This works perfectly in, I believe the year was 2467 BC. Yes, 2467 BC. That worked fine for finding north, but after a little bit of time, a few years, a few centuries, there's plenty of centuries to the Egyptians in that civilization, the pole has wandered. So instead of a point right in between being motionless in the sky and marking the point directly over the north point on the horizon, if you find that point in the sky and line your building up with it, and this point over here is due north, maybe you've not done your pharaoh any favors. And so we can look at the buildings now, and we can tell when they were built by how much the sides deviate from a north-south line because of this wandering. So astronomy and archaeology have benefited from each other's contributions. And that has now been dated. The Great Pyramid has been dated by this method to have been constructed in 2480 BC within plus or minus 10 years, based on this alignment consideration. Let's see. Let's look in here. This is a more detailed view of Kochab over here. This is Beta Ursa Minor, second brightest star in that constellation. And then we've got Mizar right in here. It's actually two stars together. It's a binary star. They're far enough apart that it's been a test of good vision since at least the time of the Romans, if you could see them separated. But right between this star and this star, you've got Thuban almost right between it, but the pole was moving this way, and I know I've turned the slide, so I played around with doing this, but I'm not real happy with that for obvious reasons, trying to read it. But each age seems to have its way to find the pole. We have the means of finding the two stars in the Big Dipper and drawing a line out of it, almost a perfectly straight line, about 5 times the separation here, leads you to Polaris. It's not an extremely bright star, but it is motionless. It helps you find directions. For a point about 4,500 years ago, find this star in the bend of the handle of the Big Dipper, find this star, which is the second brightest star in Ursa Minor, and halfway in between them, you've got the point that once you drop your gaze straight down to the horizon, you're looking due north. One speculation, and I don't know enough to be convinced of this yet. Some claim it's true and some dispute that, is that the 3 small pyramids here are representative of the belt of Orion. And certainly there was a connection between the gods, god Osiris, is also identified as the first pharaoh, whether that is a mythological characterization or not, I'm not sure, but certainly that was very important, and perhaps that's what this was supposed to represent. Major buildings in Egypt were built to align with stars or with the sun. Here we have portions in this slide, and I think just one more slide that I ended up including, from the temple of Amun-Ra at Karnak. Immense columns. I, this morning, almost snatched up another picture I found on the internet and put it on there because it had some people in the picture, and I couldn't believe how tiny they were compared to the height of these columns. These columns are about 100 feet tall. Just a little under it, 29 meters. You do the math, okay? They're tall. And this arrangement of pillars permits the rising sun to enter only on one day of the year to the inner sanctum. And that day, the first day of, well, that's curious that it was blocked out because I had 2 sources that disagreed as to what day it was. One was the first day of winter, and the other source said the first day of summer, and I had not had my chance to track down which that was. But the projector alignment has taken care of that for me. I'm not sure. But it was a significant day, and it took some engineering to get the pillars placed in just the right way, or the corners of doorways, the edges of doorways, in just the right positions so that this shaft of light could make it all the way down a very long hallway to the sanctuary. Not to be overlooked is the fact that they did have these great clear skies. And one thing that I would comment on, actually from my experience in Morocco, I went to Morocco with my family at the time of Ramadan. Ramadan ended quite coincidentally on the first day, on Christmas Day that particular year. And the Islamic calendar is a lunar calendar that also does not sync with the seasons. It's way out of sync compared to what the Egyptians had. The Egyptians were off by 6 hours. This is out of sync by, well, 29 and a half days per month per lunar cycle times 12 months. The months all start when they sight the crescent moon in the evening. Where do they sight it? In Cairo. That's where the official place is. That would be 354 days. So it's going to be about 11 and a quarter days off every year. And now, 11 years after we were there, that's close to, 4 months earlier. And eventually you get to the point where you're celebrating Ramadan not in the wintertime, but you're celebrating in the summer, and you're supposed to fast during the daylight hours. Well, that's a longer time come June than it is in December. And it's a much more of a challenge. But it doesn't matter. It's not important to them, to the practitioners, the followers of Islam, that the calendar be synced to the seasons. They just simply have, I imagine, in the modern day, they would have calendars that carry both dates, planners that have both calendars, religious activities as well as activities that conform to the calendar that the modern business world is following. I want to talk about one of the greatest achievements, perhaps, by a scientist of more than 2,000 years ago. This was about 2200 BC. The man's name was Eratosthenes. He was a librarian. Here we are in the library. How can I pass up the opportunity to talk about a librarian? He was nicknamed Beta. It was said that he was second best in the world in everything. He was a cartographer. He was a mathematician. He was really good, but wasn't tops in any field. But his job was to acquire information. And one day, from far up the Nile, and that's where the modern high dam Aswan is. Those of you over here, that's where it is. Syene was the name of the little town there. Came a report to Alexandria that the sun was straight overhead at noon on the first day of summer. The sunlight went all the way to the bottom of the wells. The tall poles cast no shadows. Now, the idea was already established that the world was round. If you've heard, as many of us were taught, that Columbus set sail at a time when the populace understood the world to be flat, that's a flat-out falsehood. That ain't so. This was established long before that. Aristotle, 150 years before Eratosthenes, had taken the reports of travelers who had gone to the north and said, hey, the North Star is higher. And those who had gone to the south said, hey, the North Star is lower. And said, oh, the Earth must be round. And he wrote that, and Aristotle's word was taken as the authority in science. Eratosthenes, when he reads this, says, don't know what he said for sure, but I really imagine that he checked the sky, the sun, on the first day of summer in Alexandria. And he did not find that it was straight overhead. Now, on a flat Earth, if it's straight overhead Syene, it's going to be straight overhead in Alexandria. But on curved Earth, it can go down the well there and cause the poles here to cast shadows. And he didn't stop there. He thought about it, realized that he had a means here of going further. If he could measure how far in angle the sun was away from being straight overhead, the zenith, he would measure that difference, he would have the same angle that these two vertical lines would intercept at the center of the Earth. And it turns out to be just the difference in latitude, 7.2 degrees approximately. So he measured the shadow angle, the deviation from straight overhead, and then what else does he need to go further? Well, what's he after? He's got this distance, and he's got the whole distance around the Earth. This angle right here, 7.2 degrees, what's the entire angle? It's 360. Whole distance around the Earth, certainly I don't know that if I'm living in Egypt 4,500 years, 2,200 years ago. But maybe I don't even know how far it is to Syene. Several stories come about here. One of them, that he paid for a survey to be conducted, paid for someone who was a pacer and a counter to hike the distance, which was 5,000 stadia. This was the distance unit used by the Greeks at the time. About 5,000 stadia. And 7.2 degrees is about exactly 1/50th of a complete circular angle. So he was looking at that distance. If he could measure it to be that equation is wrong, isn't it? Not 1/50th times s, but s divided by a 50th. 50 times s. Take the distance s and multiply it by 50. How embarrassing. I got one of my equations wrong. And how close did he come? The value that he found was about 45,000, maybe closer to 45,500 kilometers in modern units. The accepted value today is a little bit over 40,000 kilometers, about 40,080 around the equator, 40,075. But I put a question mark and an asterisk over on the right there because there is doubt about converting his units of stadia to kilometers, because the stadium as a unit of length was the length of the Olympic Stadium, and by this point in time there had been several, and they weren't all the same length. So his worst results are right here. This is as far off as he could have been, apparently. If you give him credit for using the stadium that would have given him the best results, he was off by maybe 1%. In any case, how much of the world is known in Egypt or in Greece or the Mediterranean at that time? It's the Mediterranean. It's maybe as far as Babylonia, and then beyond, maybe touching India a little bit. And maybe there's a sense of just how little of the world they know when they can see the size of the world there. When Columbus goes before the College of Scientists prior to 1492 to argue his case for being given a grant to sail westward to India and Japan, they said, "You're out of your mind. Look how big the world is. Look how far that is. You can't carry enough provisions to get there." He tried other arguments, but this measurement was cited. This measurement had been reproduced in other ways, and the size of the world was known as well as its shape. I leave you here with one more look at the Milky Way from a very dark location. I think it's a beautiful view, and we have gained greatly in our modern society and certainly in our science of astronomy, from the dark, clear skies of the Middle East. I thank you very much for coming.
Thank you. Any questions? Starry questions? This microphone is not for sound, but for taping. So if you have a question, I'll give you this to tape it. Questions about stars? I have a question, just general one. When you see all these dots in the sky,
yes,
why is it that people say connect this and this and this and make this shape, not this and this and make the other shape? I mean,
that's a very good question. Your eyes tend to be drawn to the brighter stars, and I will offer a supposition, not a certain answer, but if you have in your culture some stories to tell, and those stories are about heroes and villains, and you're sitting around the campfire and telling that story, you probably don't have an easel and a marker to draw it out, but boy, you can get creative with dots that are just up there in many different places, and you can maybe find some creative ways to to illustrate your story.
yes, I mean,
And then that gets handed down around the campfire and on to an age when maybe it's written down.
it became time honored or something.
I think so.
Any other questions? Wish upon a star. Okay, since we have no questions, it means we have all the answers. So,
Okay.
join with me in.
Thank you.
who get millions of responses. People like to be stars themselves. Look at Hollywood, if you like, or anywhere. Everybody likes to be a star. And one wise person said that 2 days ago, we had 7 billion stars, the population of the world. Everybody thinks or likes to think that he is a star. All the parents like to see their kids stars. So we had the 7 billion mark of world population 2 days ago, if you like to know that information. Now, to introduce sciences, stars, and our distinguished speaker, I'm thankful for our dean. Would you please give us a hint of what you do in sciences?
My name is Godson Obi. I'm the interim dean of the College of Sciences, and I have missed most of the presentations because of all the engagements on campus. But this one, I made time to come to. Dave Linton is my faculty member in physics and one of the well-known professors on campus because of his expertise.
This series has been going on for the last month, and we're wrapping it today. Dr. Linton is here in the afternoon, and then we have one more event today at 6 o'clock in McAfee Gym. If you would like to experience sports and dancing from ancient Egypt, we hope you will come. There will be live music, dancers, and athletes, in addition to a lecture. So we hope you'll join us there. But I certainly thank you for all your patience and expert listening over the several sessions here. Our friend here has been to almost every one. Did you miss one? I don't think so. Yes, look at that. So for 24 presentations, I think, we deserve an award there. I will leave you with Dr. Wafiq Wabi, who has expertly gathered all our speakers for this series.
Thank you, Dean Lanham, and thank you all for coming at this time at 3 o'clock on Wednesday, which you can do something else on that time slot, but thank you very much for coming. And this marks the last day of this symposium, the Ancient Egypt Symposium, popularly known as a futuristic look through ancient lenses. And it has been a joy to know more about this ancient civilization that was it was the United States of its time, I think, and they left some things for us to get the glimpse of their glory. Well, stars are fascinating and have been fascinating to people since the dawn of history. Even the dawn, you can see some stars. And you can mention, even today, the word stars. And
if we're here in Illinois, where it's not all that arid, fortunately, I guess, and we do have some light pollution. Now, before I get going very far, I do want to, I have 3 disclaimers. One, if you're expecting a talk on astrology based on the mistake that got into the paper yesterday, you may want to leave now. There is a difference between astrology and astronomy, and I wish to speak on astronomy. Secondly, I'd have to say I'm not an expert on Egypt at all, although I have significant interest in the history of astronomy, as it bears on astronomy itself. And thirdly, I've never even been to Egypt, although it's on my list. More so now than when I started reading up for this talk. So I guess maybe the next slide to look at is this that was in the paper yesterday, and I don't want to make fun of this. It was as much my mistake, probably more my mistake than anybody else's. I wasn't careful about communicating over the phone in a phone interview what I should have been alert to.
In astronomy, am I right? Okay. Okay. So today he is going to apply some of that science to an understanding of ancient Egypt. And Dave, good luck.
Now, if you wish upon a star, here it is.
Thank you, thank you both, and thank you all for coming. Um, I would start off by saying that I noticed that all the slides seem to be shifted that way, so if you'll just lean, maybe it will help. But you're probably going to, could be. That's maybe the early indication that you're going to miss a little bit off the right edge, and if that happens, hopefully I can remember what it was, because I can't see it on my screen here either. But the stars, the sky, was extremely important to the Egyptians. Remember that this was a time when there was no light pollution on this planet. And this is a desert environment, and the skies were just gorgeous. It must have been. We can only imagine